Hi, everybody. You haven't seen my face probably in a little while here, especially if you haven't been to a Google Meet, but figured I would start Unit 11 just by showing you some cool stuff here. Unit 11 is called conic sections, and I'm not sure that this will work, but I'm going to try it real quick. So if I hit present now, I'm going to try to present my screen. Let's see if this works. I don't know if it will work, but we'll give it a shot. All right, so what I actually want to show you is on this website, a conic section is when we take a slice through a cone, and this website actually has a really cool animation of the 4 different types of conic sections that are a result of slicing through a cone and what that 2-dimensional cross section looks like. So where I'm starting, this looks pretty circular to me. You can see the 2-dimensional cross section on the right side and what the 3D image looks like on the left-hand side. But if I hit this animate button and I hit pause every now and then, that looks like a perfect circle to me right now. And if I continue to animate, you can see that now we're getting a little bit more stretched out. Definitely not a circle anymore. Elodie, do you know what that shape is?
It's an oval, and when you want to bring in this picture, pick me up, and I'll tell them I made this picture and tell them all the work.
Okay, perfect. We'll do that at the end of the video, okay?
Okay.
All right, so this shape is, oval is what you would learn in kindergarten. We're going to call it an ellipse, and we'll learn all about the properties of ellipses at some point later on in this unit. If I continue to hit the animate button, I'm going to stop right here. You can see how that cross section is now hitting the base of the cone, and the resulting shape, that resulting cross section 2-dimensionally, is a parabola. So that's the third cross section. The fourth one, if I continue to hit animate, wait for it. Whoa, look at this guy. So now the cross section, the slice that I'm taking, goes through the top cone and the bottom cone, creating these 2 curves as a result. And those 2 curves would be the graph of what is called a hyperbola. So it will be a miracle if this actually worked. But let me see if I could stop presenting. Okay, and I'm back. So we're going to take some quick notes on conic sections today. Let me turn it on, see if this works. We have a picture presentation by Elodie at the end of today. You might hear my twins in just a second coming down from their nap. We'll see. Okay, so what are the 4 different types of conic sections that maybe we just saw? We saw a circle.
Hi.
We saw an ellipse, a parabola, and that last one that looked like 2 parabolas is called a hyperbola. Okay, circle is what we're going to focus on for the next couple days. So we will eventually talk about all 4 of these, but for now we're going to talk about circle. Now, circle is something that you have actually graphed in prior school years. Hey, Elodie, you got to be quiet, remember? All right, what is the definition of a circle? It is the locus of points, equidistant from a fixed point. So that's the fancy math definition for what a circle is. And actually, if we tried an experiment where we all somehow got together, even though we're not allowed, we could actually form a circle with an appropriate social distance radius by putting somebody in the middle of, let's say, like a big field or something like that, and having everyone try and stand equidistant from that person with an appropriate sized radius, of course, trying to maintain, like I said, social distancing here. And what would be formed is we'd form a circle around the person who is in the middle. All right, the equation of a circle is something that you learn in geometry. It's something that you see in Algebra 2 again. So the equation of a circle is going to be in standard form x minus h squared plus y minus k squared equals r squared. So what I'll tell you is that we're eventually going to take a look at a general form too, but this is the standard form that hopefully looks familiar to you. In this equation, the center has the coordinate hk, and then the radius is the value of r. Okay. So in our first example, we're just going to take a look at an equation that's already given in standard form. And then once we look at that equation in standard form, we'll make a quick sketch of it. Okay. Now, I don't have graph paper right now, but I'll tell you I will use graph paper for notes a lot in this unit. So if you have graph paper available somewhere, good idea to take it out, get it ready for the next couple weeks. Okay, so here's the equation of the circle. The center of the circle, according to the standard form up here, would be 1, -2. And the radius of the circle would be the square root of 25, which is 5. So if I set to sketch the circle, I'd start by plotting the center coordinate at 1, -2. So maybe something that looks like this. And then if you use a radius of 5, I'll just try and make this look somewhat accurate here. Okay, so if you go up 5, down 5, left 5, right 5, in the end you get something that looks like this. In this unit, you might find your circles start looking kind of footballish shaped, not a big deal. They're just rough sketches. But I would expect to see that you had the center in the correct place, and then that radius distance went in those 4 directions, up, down, left, right. Okay, so that should be pretty easy for us. So let's jump right into what the main part and point of this unit will be, is taking something like x squared plus y squared plus 4x plus 12y plus 36 equals 0, and also being able to sketch something like that. This is more of a general form of a circle. And the way we're going to convert from general form to standard form is by the good old process of CTS. We haven't done CTS in a while, but I'm hoping you remember that CTS would stand for complete the square. Okay, so when I go to complete the square here, I'm going to start by grouping the x terms together, group the y terms together, and then the constant, I'm just going to move it to the other side. So it's going to be x squared plus 4x plus y squared plus 12y equals on the other side -36. Once you've grouped those x terms and y terms, the next thing you're going to do within these individual groups is you're going to complete the square, once for the x's and then once for the y's. So it would be x squared plus 4x plus blank. I'll remind you in a second how we're going to fill in that blank if you don't remember. Plus y squared plus 12y plus blank equals -36 plus blank on the other side. Because whatever I add to the left side, we've got to add the same things to the right side. All right, so in this scenario, if I take the middle b term, which is 4, divide it by 2 and square it, that's how we're going to complete the square. 4 divided by 2 is 2, squared is 4. 12 divided by 2 is 6. 6 squared, 36. So to keep things balanced, we've got to add the 4 and the 36 to the other side. What we've done when we complete the square is we create what are called perfect square trinomials. Okay, so if this is a perfect square, what does it factor into? It would be the quantity x plus 2 squared. This would be the quantity y plus 6 squared. And then on the other side, if I add those numbers up, kind of convenient that the 36's cancel out, so we just get a 4. So at the end of the process here, the center of this circle would have the coordinate -2, -6, and this would have a radius of 2. Square root of 4, right, and just divide that by 2. Square root of 4 happens to be 2 as well. So if I wanted to sketch this, I could do it pretty quickly. This one's kind of unique because if you do sketch it, it's going to be tangent to one of the axes. See if you remember what that word is. So -2, -6 might be down here somewhere. And if you go 2 to the right, 2 to the left, 2 up, and 2 down, you're going to get a graph that looks like this. So when I go 2 to the right, you'll notice that I just touched the y-axis there. So we would say that this circle is tangent to the y-axis. Okay? All right, so we should probably do a little bit more practice converting by completing the square, but this is something that you definitely learned in geometry. Definitely. So hopefully it somewhat looks familiar. It's not completely foreign to you guys. Okay. All right. So if I gave you x squared plus y squared minus 10x plus 4y minus 12 equals 0. If you feel pretty confident about the process that I just showed you, hit pause for a second, try it, and then check back in a moment to see if you've completed the square correctly. All right, I'm going to jump right into it, though. Group those x's, group the y's, add the 12 to the other side. With my group of x's and my group of y's, we have to complete the square. So it's going to be x squared minus 10x plus blank. -10 divided by 2 is -5. Squared is 25. y squared plus 4y plus blank. 4 divided by 2 is 2. Squared is 4. So on the other side, we also have to add 25 and add 4. So now this perfect squares that I've created become x. Just be careful of the signs. If the middle sign's negative, it has to be x minus 5 squared. This would become y plus 2 squared. 12 plus 25 plus 4 is a total of 41 on the other side, I think, if I've added those correctly. So the center of the circle is at 5, comma, -2. The radius is, well, that's definitely not a perfect square, so I'm just going to express it as radical 41. You don't have to do anything else with that. If it said round, that's fine, but I'll say more often than not, you'll see these left in radical form. One more like this. And then we'll talk a little bit about working backwards with conic sections and circles here. All right, so if I give you x squared plus y squared minus 3x minus 4y equals 0. Okay, so in this scenario, the only thing that maybe looks a little bit different is that I didn't give you a constant term like I had in the last two examples, so you just don't have to move that over to get started. You can group the x's, group the y's right away, and then go ahead and complete the square. So for the x's, it's going to be x squared minus 3x plus something. All right, it's a little bit tougher, I guess, if you have that b term that's odd. It's not impossible, guys. You have calculators. You should be pretty good even at squaring fractions. But if you do 3 divided by 2, that's 3 halves. Square it, you get 9/4. I really think it's easiest to leave it as a fraction, right? Square the top, square the bottom. So then hopefully we're pretty good that that's a 4 by now. On the other side, don't forget to add the 9/4 and then add 4 to keep this balanced. So if I factor this, what students have a little bit of a tough time with is what would that break down to? What is this a perfect square expanded form of? It's going to be x minus the 3 halves squared. So remember that b divided by 2, that number would be -3 halves. When I square that, that's how I'm going to get that 9/4 there. So b over 2 is the number that will always be in this position right here. What was b over here? 2 here, -2. So this is y minus 2 squared. 9/4 plus 4. Well, I don't really love the way that looks because to add fractions, you need a common denominator. I'm going to get fancy for a second and say that 4 is really 16/4, isn't it? 16 divided by 4 would be 4. So now that I have a common denominator, 16 and 9 is 25/4. And the center of the circle would be at 3 halves, 2. And it may look scary, but this is a nicer radius than the last one. Square root of 25/4 is 5 halves. Square root top, square root bottom. So don't be afraid of odd b values here when you're completing the square. And don't be afraid of fractions that come into the mix. We can still get nice radii to pop out of those. Last thing that we have in this quick intro to conics lesson with circles today is a little bit of working backwards. So what I mean by working backwards is now I'm going to give you some info about the circle, and we're going to write the equation. So let's start with something that's pretty straightforward. If I told you the center was at 6,3 and that the radius is 4, what's the equation? Well, if we can identify the center and radius when given the equation, hopefully we can work backwards to say that this would be x minus 6 squared plus y minus 3 squared. And at the end should be the radius squared, which would be 16. So that's super fast if I know that information. Number 2. The center is going to be at 3, -2. And the circle passes through the point 5, 1. All right, in this scenario, to figure out the equation of the circle, hopefully you can see that clearly what's missing is the radius. Now the radius in this scenario is going to be the distance from the center to this point that's on the outside of the circle. So you can do a few different things. You can find the distance between those 2 points, if you remember the distance formula. That's actually how I traditionally have taught this. But I find that students are a little bit better when they write this. Write down what the equation would be with the center that's given. And at the end, just put r squared. So if I do x minus 3 squared and y plus 2 squared, that's definitely a good start for what the center is. To figure out what r squared is, you can actually just plug in the point that you're given. So 5 minus 3 squared plus, plug in the 1 for y, if this is a point that's on the circle, then when I plug it in for x and y, that should give me the value for r squared. 5 minus 3 is 2, so 2 squared is 4. This is going to be 3 squared, which is 9, which gives me that r squared is 13. I realize that means that the radius is radical 13, but you don't even have to go that extra step, because remember, what we really need at the end of the equation is the value of r squared. So if r squared is 13, just put a 13 at the end, and that would be it. That's probably the most direct way of getting that answer. Answer keys of mine in the future might have the distance formula. In fact, I'll kind of show you real quick that the way I did this originally in my notes is I plugged it into the big radical distance formula, got the same radius value in the end. So not a huge deal if you do it that way. But the last scenario I want to look at today is if I gave you the endpoints of the diameter. So in the last scenario, working backwards, I'm going to give you the ends of the diameter of the circle. Hopefully that circle terminology is pretty strong there. You know what the diameter is, right? All right, the ends of the diameter at -1, 7, and then also 9, 3. If I give you the endpoints of the diameter, what we don't know that we've known in the last two cases is the coordinates for the center. So I have to figure out what's midway in between -1, 7 and 9, 3. If you have graph paper, I guess you can sort of, map it out. Here's -1, 7. 9, 3 might be, this point over here. So the circle, if these are the endpoints of the diameter, probably looks something like this. And the center of the circle is, if I'm being somewhat accurate about my sketch, maybe right about there. So I guess I could do some counting on a grid if I had it, but without a grid, how else do we find the middle point between two ends of a segment? Well, you caught on to my hint there. We're going to find the midpoint. Midpoint in general is average the x's. So add the x's divided by 2. Do the same thing with the y's. Average those. So if I do that, -1 plus 9, this is going to be to find the center. -1 plus 9 is 8, divided by 2 is 4. 7 plus 3 is 10, divided by 2 is 5. So we now know the center is at 4, 5. Yeah, that definitely looks like 4, 5 to me. I don't know about you guys, right? Okay, so we've got 4, 5 for the center. How do I find the radius? Well, we can now do exactly what we did in the last question. Set up the formula with the center. X minus 4 squared plus y minus 5 squared equals radius squared. And now choose either endpoint of the diameter. It really doesn't matter because they're both on the circle. I don't know, I kind of like positive numbers best, so I'm going to do 9, 3. 9 minus 4 squared plus 3 minus 5 squared equals r squared. 9 minus 4 is 5. 5 squared is 25. This is going to be -2 squared. Just make sure you keep that a positive 4. Okay, so r squared in this case is going to be 29. So the end equation using that center and my r squared value of 29 would look just like this. Okay, so that brings us to some homework from the textbook. The homework for circles, which I hope goes pretty quickly for you, is section 6.1, numbers 11 to 21 odd, 22, and then 23 to 43 odd. Okay. Let me know if you have any questions about today's video or any of those practice problems. And we've got a little bit more circles coming your way tomorrow. Have a great day, guys.